The idea of turning Mars into a second Earth, a process we call terraforming, is one of the most ambitious and thrilling concepts ever imagined. Picture this, the rusty red sky slowly turning a familiar shade of blue. Vast, frozen deserts transform into rolling green hills and deep blue lakes. Humans, no longer confined to cramped domes, build cities under an open sky, breathing the air without suits. This is the green dream of Mars, a vision that has fueled science fiction and scientific speculation for decades. It promises a backup plan for humanity, a new world to explore and cultivate, and perhaps the ultimate achievement of our civilization. But before we can paint this new world green, we must first understand the canvas we are starting with. Mars, as it is today, is a profoundly hostile world. It is a cold, radiation-blasted desert. The average temperature is a deadly -60 degrees Celsius, cold enough to freeze carbon dioxide. The atmosphere is incredibly thin, about 1% of Earth's, and is composed mostly of carbon dioxide. This means there is no air to breathe, and no atmospheric pressure to keep the water in your body from boiling, even at those freezing temperatures. The surface is constantly bombarded by solar and cosmic radiation because Mars lacks a global magnetic field to deflect it, unlike Earth. In short, the surface of Mars is more inhospitable than the most extreme environments on Earth. This is the reality. This is the starting point for the greatest remodeling project in history. The gap between the Mars we have and the Earth we want is so vast that bridging it would require us to become planetary-scale engineers, manipulating the very fundamentals of a world. The question is not just whether we can, but whether we should, and what terrifying risks we might unleash in the process. The first and most fundamental challenge is the Martian atmosphere. To make Mars livable, we need a thicker, warmer atmosphere with breathable oxygen. The current thin coat of carbon dioxide is not enough to trap the sun's heat, a phenomenon known as the greenhouse effect. On Earth, our atmosphere acts like a blanket, keeping the planet warm. Mars has lost its blanket. So, the first step in any terraforming plan is to thicken that atmosphere and jumpstart a runaway greenhouse effect. Scientists have proposed incredible, almost godlike methods to achieve this. One idea is to build giant orbital mirrors, hundreds of kilometers across, to reflect sunlight onto the Martian poles and vaporize the frozen carbon dioxide stored there, releasing it into the air. Another, more drastic idea, is to redirect comets and asteroids rich in ammonia, a powerful greenhouse gas, to crash into Mars. These impacts would not only release gases but also add water. The most discussed method, however, involves manufacturing greenhouse gases directly on Mars, creating super-polluting factories whose sole purpose is to heat the planet. This is phase 1, deliberately engineering a climate catastrophe on Mars to make it warmer. It is a dangerous and unpredictable experiment on a global scale. When we talk about deliberately changing an entire planet, the scale of the unknowns is staggering. We are not simply building a city, we are attempting to reprogram a world's entire climate and geological history. The first and most immediate danger lies in the sheer unpredictability of complex systems. On Earth, our climate models are incredibly advanced, yet they still struggle to predict the long-term effects of our own, much smaller, global warming. With Mars, our data is limited to a handful of rovers and orbiters. We do not fully understand the planet's subsurface, the composition of its soil in every region, or the intricate ways its thin atmosphere interacts with the surface. What if our attempts to warm the planet trigger a chemical reaction in the soil that releases a toxic gas? What if the new atmospheric pressure causes vast, unstable regions to collapse? We would be conducting this experiment with no real way to hit the undo button. Another profound danger is the potential for catastrophic resource release. We often talk about the water on Mars being locked away in polar ice caps and subterranean glaciers. But what if that water is not as pure as we hope? Martian soil is known to be rich in perchlorates, which are toxic chemicals that can damage the human thyroid and nervous system. As we warm the planet and melt the ice, we could be unleashing a global tide of contaminated water, poisoning the very oceans we are trying to create. Furthermore, we have no idea what might be sleeping in the deep ice. On Earth, ancient permafrost has been found to contain long-dormant viruses and bacteria. If Mars ever had ancient, simple life, its remnants could be preserved in the ice. By thawing the planet, we might be inadvertently exposing Mars and any future Earth life there to completely unknown biological agents. We would be blindly mixing the biological recipe of two worlds. The ethical dilemma is equally immense. The central question is, do we have the right? If Mars is, and always has been, a dead world, then perhaps the argument for changing it is stronger. But what if we are wrong? What if, in the deep subsurface, there are resilient Martian microbes, the last descendants of a lost biosphere? By terraforming Mars, we would be committing planetary genocide, wiping out the only other known life in the universe to make room for ourselves. We would be replacing a pristine, alien world with a second-rate copy of Earth, forever erasing its own unique history and scientific value. The process of making Mars Earth-like would inevitably involve introducing Earth organisms, bacteria, algae, and lichens to jumpstart an ecosystem. These engineered extremophiles could outcompete and exterminate any native Martian life before we even have a chance to discover it. The danger is not just physical, it is philosophical. Are we stewards of life, or are we cosmic conquerors? Imagine pushing the first domino in a chain you cannot see. This is the peril of geoengineering on a planetary scale. Our interventions on Mars would not be isolated events, they would trigger a cascade of unintended consequences, a domino effect that could spiral completely out of our control. For instance, let us say we succeed in warming the planet enough to melt the southern polar ice cap, which contains a massive amount of frozen carbon dioxide in water. This release would thicken the atmosphere and cause more warming, which is what we want. But it could also destabilize the entire region. The sudden release of pressure and weight could trigger massive Martian quakes, something our limited seismic data suggests do occur. This planetary shuddering could fracture the crust, potentially disrupting the very foundations of our future colonies. Furthermore, as the atmosphere thickens, the weather patterns would become increasingly violent and unpredictable. Mars is known for its planet-wide dust storms that can last for months. A thicker, more energetic atmosphere would supercharge these storms. We could be looking at hurricanes of red dust larger than continents, with winds whipping at incredible speeds, scouring the landscape and making any surface operations impossible for years at a time. These storms could also cover our solar panels, freeze our machinery, and block out the sunlight we are relying on to continue the warming process. We might accidentally create a self-perpetuating cycle of violent weather that actively works against our goal, turning Mars into a stormy hellscape rather than a tranquil new Eden. The most frightening domino of all involves the long-term stability of the new environment we create. Let us assume we overcome all odds and create a warm, thick, oxygen-rich atmosphere on Mars. Could we maintain it? Mars lacks the active plate tectonics and a strong magnetic field that help regulate Earth's climate and protect its atmosphere. Without a magnetic field, the solar wind would constantly strip away our newly created atmosphere, slowly bleeding it off into space over millions of years. This means any terraformed Mars would be a temporary state, requiring constant, active maintenance to prevent it from slowly reverting to a dead world. If human civilization on Mars ever faced a collapse, the descendants of the colonists would not just see their cities fall, they would watch their very sky dissolve, slowly suffocating and freezing in a dying world their ancestors built. We would be creating a fragile, artificial biosphere that could collapse catastrophically, dooming future generations. The ambition to terraform Mars carries a staggering financial and resource cost, a burden that would inevitably fall upon the people of Earth. The energy and material requirements for such a project are almost beyond comprehension. We are talking about manufacturing and launching thousands of giant orbital mirrors, or developing the technology to nudge asteroids across the solar system, or building and powering countless automated factories on Mars to produce greenhouse gases for centuries. The initial investment would be in the trillions, perhaps even hundreds of trillions, of dollars. This raises a critical question: is this the best use of our collective wealth and ingenuity? At a time when Earth faces its own existential crises, climate change, biodiversity loss, poverty, and resource scarcity, diverting such immense resources to a different planet could be seen as the ultimate neglect of our home world. The technology and innovation required to warm Mars could instead be used to repair Earth's climate. The money spent on sending a single terraforming drone to Mars could fund the development of clean energy for entire nations. Choosing to build a new Earth instead of fixing the one we have could create a deep moral and political divide on Earth, between those who dream of the stars and those who struggle for survival on the ground. It could be perceived as a project for a wealthy elite, abandoning a troubled Earth to create their own private world. Moreover, the very act of terraforming Mars sets a dangerous precedent for how we treat planets. If we can remake Mars in our image, what is to stop us from doing the same to Venus, or the moons of Jupiter and Saturn? This mindset of planetary engineering could lead us down a path of treating celestial bodies as raw materials for our expansion, rather than unique worlds to be understood and preserved. The cultural and psychological impact on humanity would also be profound. Creating a second Earth might provide a short-term sense of security, but it might also subconsciously encourage a disposable planet mentality. If we mess up Earth, we always have Mars, right? This could undermine the urgency of solving our problems here and now. The terraforming of Mars is not just a scientific challenge, it is a mirror held up to humanity, forcing us to ask who we are and what we value most. Once the process of terraforming begins, it is almost certainly irreversible. This leads to one of the most profound dangers, the question of governance. Who gets to decide the fate of an entire planet? There is no United Nations on Mars. In the early days, the effort might be led by a single corporation or a single nation that possesses the required technology and capital. This could lead to a new form of cosmic colonialism, where a private company or a powerful country effectively owns and controls a world, dictating its laws, its economy, and its future. The ownership of Mars could become the greatest source of conflict in human history, dwarfing any terrestrial war. As the environment becomes more Earth-like, the competition for the most valuable land, the shorelines of new seas, the fertile river valleys, would be intense. This could create a brutal, gold rush-like scramble, potentially leading to violence and warfare on Martian soil. The terraforming process itself could be weaponized. A faction controlling the orbital mirrors or the greenhouse gas factories could hold the entire planet hostage, threatening to plunge it back into an ice age or overheat it into a Venus-like hellscape if their demands are not met. The technology that gives us the power to create a world also gives us the power to destroy it. The legal and ethical framework for such an undertaking is completely non-existent. Do we apply Earth's environmental protection laws to Mars? How do we manage the introduction of millions of Earth species to form a new ecosystem? What rights would any potential native Martian life forms have? The decisions made would echo for millennia. If we succeed, the society that emerges on Mars would be shaped by these foundational, and potentially unjust, decisions. We risk not only creating a new planet but also creating a new, deeply unequal, and volatile human society, born from a process that was undemocratic and controlled by a powerful few. The danger is that in our quest to save humanity, we end up creating a world that reflects our worst impulses, greed, conflict, and the will to dominate. After considering the immense dangers, the ethical nightmares, and the staggering costs, we must ask, is there a better way? The dream of humans living on Mars does not have to be abandoned, but perhaps the goal of terraforming should be. Instead of trying to transform the entire planet at a reckless speed, we could adopt a more cautious, sustainable, and respectful approach. We could focus on creating contained, self-sufficient habitats. Imagine vast, transparent domes housing lush biospheres, or networks of underground cities carved into canyon walls, shielded from radiation. These habitats could be scaled up over time to support large populations, all without altering the native Martian environment. This path is technologically within closer reach and carries far less risk. This approach allows us to have a presence on Mars while preserving it as a unique world for scientific discovery. We could continue to study the planet's geology and search for signs of ancient or extant life without the threat of contaminating or destroying it. Mars holds the history of our solar system in its rocks and ice. By keeping it pristine, we preserve a scientific laboratory of unparalleled value. Furthermore, learning to build and maintain perfect closed-loop ecosystems in these habitats would provide us with invaluable knowledge that could be directly applied to managing Earth's biosphere more effectively. The challenge of surviving on Mars as it is could teach us how to live more sustainably on Earth. The narrative of humanity's future in space does not have to be one of conquest and planetary remodeling. It can be a story of adaptation, harmony, and subtlety. We can learn to live with the galaxy, not simply dominate it. By rejecting the dangerous experiment of terraforming, we make a conscious choice to be responsible stewards. We choose to fix the problems on our first planet before claiming a second. We choose to value alien landscapes for their own sake. The greatest achievement for humanity would not be to make Mars look like Earth, but to prove that we are wise enough to explore the cosmos without destroying it. The red planet can be our companion in the cosmos, a testament to our ingenuity and our restraint, rather than just another victim of our ambition.